Hello, Dan Harvey for Boris Effects here with an overview of the new Megaplate toolset in Mocha Pro 2020. Megaplate uses Mocha's tracking and temporal flame analysis features to build high-resolution images which extend beyond the canvas of the original footage when the camera is moving, enabling a range of set extension, match moving and matte painting workflows. In this session I'll be running Mocha Pro as a plugin for Autodesk Flame. In Flame's batch workspace I have a panning foreground clip into which I plan to insert a cloudy sky from a second clip, but the motion of the clips doesn't match. I'll drag an OpenFX node into the schematic, select Mocha Pro from the plugin list and launch the Mocha UI on a floating window. I'll draw a shape, outlined in red, in which to track the motion, name it and enable the surface overlay in blue which indicates the plane defined by the track. I'll hit the track forward button to begin tracking. The default behaviour of Mocha is to link the motion of the track back to the original shape, but in this case the shape will eventually be carried out of the frame and lose the track as a result. Linking the shape to no track enables the shape to remain in a static position whilst generating the track data, shown by the blue surface overlay. Processing speed is dependent upon compute resources, and as I'm working on an older MacBook I'll fast forward. It's worth noting that pan and zoom with the X and Z hotkeys remain interactive during processing, enabling close inspection. I'll hit the Fit Surface to Frame button to maximise the size of the surface and expand the shape to accommodate the full range of track motion, adding points and adjusting point tension on the shape as required. Now I'll switch to the Megaplates tab. Park on a frame where the surface is aligned, typically at a point midway through the move, enable Auto Step, set an edge blending value to smooth the edges of interpolated frames, and hit the cog button to render the Megaplate, which fills the area defined by the shape. In order to save the Megaplate as a high-resolution file, I'll hit Create and specify the path. The file size in pixels may be user-defined, or in this case calculated automatically as autoscale is enabled. Now I'll return to batch and measure a track for the cityscape clip with an unlinked shape as before. I'll assign my exported Megaplate frame as the insert clip for the layer I've tracked. I'll expand the image by hitting the Fit Track to Frame button and further adjust the scale and rotation with the transform controls in the Insert menu tab. I can now add a static shape and surface, add the input clip of the cityscape as an insert for the foreground layer above the track Megaplate, return to batch and feed the output of a keyer node to the Mocha node's matte input socket and enable the interactive render of the insert effect for the two layers. In the next example I'll use Megaplate to transform a 360-degree panning shot into a 3D environment map for shading imported geometry in Flame's Action module. I'll repeat the steps shown in the previous example to measure the track with an unlinked shape, expand the shape to accommodate the full range of track motion, fit the surface to the frame midway through the track motion, render and save the Megaplate image file whose size is automatically set to around 16K. This is rather more than I needed in this case, so I'll connect it to the background input socket of an 8K action node, add it into the composition as an image and change the image type to extended by cubic so that I can warp it to fill the frame as required. Next I'll connect the original live action clip to the background input of a new action node, add a media input and connect the warp Megaplate image to it. I'll import my 3D model, select it in the action schematic, align it and examine it with a default point light. In order to blend the model more convincingly with the background, I'll right-click the camera node in the action schematic and select an image-based lighting node from the contextual menu. This uses the selected media input from the Megaplate image as an immersive 3D ambient light source.
I'll change its mode to reflection so that my model reflects it from the centre of the composition, and adjust the gain so that the reflection is brighter. I now have full control over the mapping coordinates and image orientation in 3D space to ensure that the background is reflected correctly from any camera angle in the composition. Now I need to track the motion. I could measure the track with Flame's native tracker, but this is unnecessary as I've already tracked it in Mocha. I'll return to the Mocha UI, select my track layer, and export the track as a Flame point tracker setup, which generates separate files for each corner and centre of the track plane. I'll return to the action schematic where I've set the orientation for the model with its parent axis. So I'll add another axis above it, enter its tracking menu, and import the track data for the centre that I exported from Mocha. As a finishing touch, I'll enable motion blur and action preferences and match the motion blur on my track model to that in the background clip. As we've seen during this session, the Megaplate functionality is a powerful addition to the Mocha toolset, enabling greater efficiency and precision in map painting and 3D relighting workflows. Keep in mind that the Mocha functionality shown here is also available in Nuke, Adobe, or any other supported host application. For more tutorials on Mocha and the rest of the Boris Effects product family, check out the training pages at boriseffects.com.